In this tutorial, I am going to explain how to simulate an active low-pass filter using LTspice software. Okay, before starting the simulation, you need to create a new folder to save all the files regarding with the simulation. Make that folder and open the LTspice software and go to a new schematic. And first we need to add the op-amp model. To add that, go to the add in components option and select the general op-amp model, which is named as op-amp 2, and place it. After selecting the op-amp, you can add the voltage sources. For this simulation we need 3 voltage sources, 2 voltage sources for the op-amp supply voltage and one for the uh, input for the low pass filter. After placing the voltage sources, you can add resistors. Once you click on the resistor icon, if you need, you need to change the orientation of that symbol before placing it on the uh, sketch. By pressing the left uh, mouse button, you can place these components. You need 3 resistors, 2 for the feedback circuit and 1 for the low pass filter, and after that you can add a capacitor for the low pass filter. After adding these components, you can add ground terminals for the circuit. Then you can start to complete the circuit using the wires. You can use your left mouse button to place these wired connections between components. Finally, you need to wire the uh, supply voltages for the op-amp. Okay, after completing this circuit, you can define the voltage values for the source voltages. So I will place 15 volts for both source voltages, and I will rename the input voltage source as an AC source. After that, we need to download the spice model for the op-amp. For this simulation we are using LM741 op-amp. So Google that op-amp name and uh, download the spice model for the op-amp. At the beginning of the site, you can see all the parameters of this op-amp, and you need to scroll down to find out the spice model and download it and save it on the created folder at the beginning of the simulation. You can extract that file, and after extracting you will receive a .mod file. Then we are going to add the uh, spice directive to assign the spice model into this op-amp. To uh, include it, you need to type .include, and you need to paste the exact file name of this spice model, lm741.mod. You can copy that and paste it after the .include operation, and you can place it at any place of the diagram. Then we need to rename the op-amp. To rename it, go to the spice model and open that with using the notepad, and select the subcircuit name, copy it, and rename the op-amp using that subcircuit name. Now we have completed the configuration part of the op-amp. Then you need to assign resistor and capacitor values for this simulation. For this simulation, I'm using 3435 registration number, and the relevant resistor and capacitor values are shown in this folder. You can add relevant resistor values with the help of the instruction file. To assign values for the components, you need to right click on the component, and you can add these capacitor and resistor values. Now we have assigned all the capacitor and resistor values and the voltage values of the sources and the LTspice model for the op-amp. Now we can start the simulation using run command, and we need to add uh, AC analysis uh, components to start the simulation. So type of the sweep will be decade, and the number of points per decade will be 10, and the start frequency is 1 Hz and the stop frequency is 5 kilohertz. And we need to add one more thing, the input uh, label and the output label. So you can add them, one label for the input and another label for the output. Okay, now we can restart the simulation. Okay, to add components to the simulation, you can use this node, or you can right click on the simulation window and go to add traces. I will use that command, and for this simulation I'm going to plot V out divided by V in. So you can select the V out and divided by V in and then press OK. So this is the gain of the this active low pass filter. Bold line represents the gain of the output signal, and these dotted lines represents the phase change of the output signal relevant to the frequency values. So to find out the cutoff frequency, right click on the label at the top of the graph and add a cursor. By using this cursor, you can find out the maximum gain of the op amp as 20.8, and you can find out the gain at the cutoff frequency by reducing 3 decibels from this maximum gain of this filter. It will be 17.82. So you can set the gain value to 17.8. So we can set that to a closer value 17.83. It is very close to the 17.82. So the phase change is minus 44.91. So it is very close to the minus 45. So we know that this is the cutoff frequency of this filter. So the cutoff frequency is around 134.83 hertz. So in this way you can find out the cutoff frequency of any low pass or high pass filter, and you can also find out the phase change at the cutoff frequency. And this is the summary of this simulation. Okay, thank you.